The countdown has begun, marking the start of a new chapter in human history. Mars, the rusty red planet that has captivated our imaginations for centuries, is about to become our next home. Its barren landscapes and mysterious allure have long been the subject of countless stories and scientific inquiries. No longer the stuff of science fiction, the colonization of Mars is rapidly transitioning into a tangible reality. What was once a distant dream is now within our grasp, thanks to relentless innovation and determination. This extraordinary endeavor is fueled by scientific curiosity, technological advancement, and the indomitable human spirit of exploration. Every step forward is a testament to our collective ingenuity and perseverance. We are driven by a fundamental desire to push the boundaries of what's possible and to secure a future for humanity beyond Earth. The quest to inhabit Mars is not just about survival, but about thriving in new frontiers. The journey ahead will be fraught with challenges, but the rewards promise to be immeasurable. Each obstacle we overcome brings us closer to a new era of human achievement. As we embark on this audacious journey, we carry with us the hopes and aspirations of generations past and the promise of a future where humanity becomes a multi-planetary species. Together, we will write the next chapter in the story of human exploration. Before humans set foot on Martian soil, robotic explorers serve as our eyes and ears, tirelessly working day and night, diligently surveying the red planet, gathering crucial data and sending it back to Earth. Rovers like NASA's Curiosity and Perseverance have traversed the Martian landscape, analyzing soil composition, studying rock formations, and searching for signs of life, all while enduring the harsh Martian environment. Orbiters like NASA's Mars Reconnaissance Orbiter provide a global perspective, mapping the Martian surface, studying its atmosphere, and identifying potential landing sites. The data collected by these robotic missions is invaluable for planning human missions, offering insights into the planet's climate and geology, helping us develop strategies to mitigate risks, ensure safety, and design life support systems that can sustain human life in space. Each discovery brings us closer to answering fundamental questions about our place in the universe, the history of Mars, and the possibility of life beyond Earth, igniting our imagination and driving our quest for knowledge. While robotic missions provide invaluable data, there is no substitute for the human element in space exploration. Leading the charge are NASA and SpaceX, each developing critical technologies for human missions to Mars. NASA's Artemis program aims to establish a sustainable presence on the Moon as a stepping stone to Mars. SpaceX is developing the Starship, a fully reusable spacecraft designed for interplanetary travel with the goal of establishing a self-sustaining city on Mars. Both are working on advanced life support systems, radiation shielding, and in-situ resource utilization techniques to sustain humans on Mars. The first human missions to Mars will be exploratory, focusing on establishing basic infrastructure and conducting scientific research. Initial habitats will likely be prefabricated modules sent from Earth, offering protection from the harsh Martian environment. These early outposts will be designed for self-sufficiency, relying on advanced life support systems and in-situ resource utilization technologies. Energy generation will be crucial, with solar panels and potentially nuclear reactors providing power. Greenhouses will be established to cultivate food, utilizing hydroponics and aeroponics. 3D printing technologies will be employed to construct habitats using Martian regolith. The focus of these early settlements will be on survival and scientific discovery. Surviving on Mars requires overcoming numerous challenges, from the lack of breathable air to the extreme temperatures and high radiation levels. Advanced life support systems are essential for providing breathable air, clean water, and protection from the harsh environment. These systems must be reliable and efficient to ensure the safety and well-being of astronauts. Oxygen generation will be crucial, with technologies like the MOXIE experiment demonstrating the feasibility of producing oxygen from the Martian atmosphere. This technology could pave the way for future missions and long-term colonization. Water recycling systems will purify wastewater and potentially extract water ice from the Martian subsurface. Efficient water management is vital for sustaining life and supporting various activities on Mars. Radiation shielding is another critical consideration, with habitats needing to be shielded using Martian regolith or water ice. Protecting astronauts from harmful cosmic rays and solar radiation is essential for their long-term health. Waste management will also be essential, with closed-loop systems recycling as much waste as possible. Efficient waste management helps in reducing the need for resupply missions from Earth. These technologies will be vital for sustaining human life on Mars. They will enable astronauts to live and work on the red planet, paving the way for future exploration and potential colonization. Beyond life support, colonizing Mars will require overcoming numerous other obstacles. The Martian environment is harsh, with extreme temperatures, dust storms, and harmful radiation. Habitats will need to be well insulated and equipped with advanced heating and cooling systems. Dust storms can last for weeks, blanketing the planet in a thick haze that blocks sunlight and can damage equipment. Habitats will need airtight seals and filtration systems to prevent dust infiltration. The lack of a global magnetic field means the surface is bombarded by harmful radiation, necessitating radiation shielding. These challenges will require innovative solutions to ensure the safety and well-being of Martian colonists. The long-term vision for many is the terraforming of Mars, transforming the planet into a more Earth-like world. This would involve altering the Martian atmosphere, temperature, and surface to create a more hospitable environment. One proposed method is to release greenhouse gases into the atmosphere, trapping heat and warming the planet. As the planet warms, the Martian ice caps would melt, releasing water vapor and potentially creating bodies of liquid water. Terraforming Mars is a monumental task that would require centuries or even millennia to complete. The colonization of Mars is about ensuring the long-term survival of our species. By becoming a multi-planetary species, we reduce our vulnerability to existential threats on Earth. As the Martian colony grows, it will develop its own unique culture and identity. The challenges and opportunities of living on another planet will shape the values and aspirations of Martian colonists. The Martian colony will also serve as a hub for further exploration and scientific discovery. The colonization of Mars is a testament to the enduring human spirit of exploration and our capacity to overcome challenges. The journey to Mars is a stepping stone to a future among the stars. By establishing a permanent human presence on another planet, we open up possibilities for exploration and discovery. The technologies developed for Martian colonization will pave the way for future missions to more distant destinations. The colonization of Mars is a bold and ambitious undertaking, but it is within our reach. With continued investment and innovation, we can make this dream a reality. The future of humanity lies not only on Earth but among the stars, and Mars is our first step on this incredible journey.